So here we have a pretty complex problem with this car locking system. The only saving grace is that unlike in the previous two problems, that you didn't have to come up with the state representation. We told you this time what to use. It said use these instance variables here, and that is really going to be very helpful in solving that. So we have three instance variables. Door is open, that's 0 or 1, depending on whether the door is currently open or not. The gear lever, that's 0 for park and 1 for drive. And the key lock, that's 0 for, well, I guess it's our choice what to make it. But let's say it's 0 for locked and 1 for unlocked. So let's look at the logic of these various methods. So we're asked to implement 4 methods, I believe. And we might as well do some of the easy ones first. So set gear lever here seems like an easy method to do. We're given a gear value that's 0 or 1, and we're supposed to remember it. Where do we remember it? There was only one choice, namely in the gear lever variable up here. So the implementation of that is one of those very simple remember methods. You're given a parameter and you set the instance variable to that value. How about another simple method, the toggle key lock? Well, it's supposed to toggle it between 0 and 1, and when you want to toggle something between 0 and 1, the trick is quite simple. You just say key lock equals 1 minus key lock. Why does that work? Well, suppose that key lock was 0, and then 1 minus key lock is 1 minus 0, that's 1. And suppose key lock was 1, then 1 minus key lock is 1 minus 1 is 0. So you can see that the 1 minus just turns a 0 into a 1, and 1 into a 0. It's pretty similar to what you've seen in the previous problem with the robot, where we wanted to toggle between 1s and minus 1s. There we did it by multiplying by minus 1. Here it's a slightly different transformation. Now we get to the hard part, and so this push door open button. So let's see, when can we open the door? And there are 3 conditions that need to be fulfilled. First, the door must not already be open, because if it was already open, then we shouldn't set the signal to open it. Second, we must be in park. And the third is that the key lock must be off. And so the trick is, we want to generate a number 1 when all of these 3 are true, so the result has to be something times something times something, where each of these 3 should be a 1 for the result to be 1. That's how we do the AND of these 3 conditions. So there's a bit of a challenge with, we can't just multiply 3 instance variables because they happen to be there in the wrong state. So let's look at the park, for example. So the gear should be in park. That means we want a 1 when the gear is 0, so we actually need to use 1 minus gear here. And the same thing with the key lock. The key lock must be off, so we must be using 1 minus the key lock state. And as it happens also with the door open, we have to take 1 minus door open. And so that's in fact the code that you find here. Now there's a minor subtlety here, is that I'm now computing whether, what the result is. This is the signal that should be sent to the motor, and I will eventually return the result. But there's another thing that this method has to do. It also has to update the door is open instance variable. And I have to be a little bit careful how to do that. I can't simply say the door is open equals result, because if the door was already open, no more signal would be sent to the motor and result would be 0. So instead what I have to do is I have to somehow find a way of combining the two. And I actually had a hard time imagining how that went, so I just made myself a little table here. Let me show you how I did that. So if the result was 1, that means that the door must not have previously been open, and then afterwards I want the door open to be 1. So if I do it before, after here. If the door was already open, well, then I knew the result had to be 0, and I still wanted the door to be open afterwards. The other combinations can't actually ever happen. If the door is already open, then, like I said, then the result will be 0 because of the 1 minus door is open in the product. And conversely, when the door, well, actually, the other thing that could happen is the door was not open, and the result was 0 because one of the other conditions wasn't working right, like that darn gear shifter or whatever. I speak with passion here because I have such a car. In that case, the door still isn't open, and my wife yells at me for doing it wrong. So the point is that these are the combinations that can happen. Like I say, if the door is open, the result can never be 0. That can't actually happen, so we don't have to worry about it. Now we need to find some way of combining the numbers so that we get the right after result. And if you look at the rows, you can see that adding up the entries will work just fine. Like I said, I had to actually map this out in my mind, and I couldn't do it in my mind, so I did it on a piece of paper. And then I realized that this formula here is the right formula. And as the final twist here is, note that this formula changes the value of door is open, so it's important in which order you do the computation. You first must see what is the signal going to be, and you're going to have to return it, so you have to save it in an intermediate variable. Then you update the door is open state, and then you return the signal value. So this really is pretty tricky, and if you got that right, definitely pat yourself on the back. Closing the door is almost the same thing. It's a little bit easier because the gear lever isn't needed here. So you can close the door if the key lock is off and the door is currently open, then one sends the signal there. And now to do this computation whether the door is still open, make yourself a similar table to what I've just done, and you see that the subtraction thing here will work. I'm sure there are many other ways of doing the same thing, but this is short and sweet and elegant. And that's all the methods, and with that, when you try that, you'll see that all the various test cases pass.